Good evening, I'm Scott Robbins, W4PA, Amateur Radio Product Manager for Ten-Tec Incorporated, and we are here tonight again with another edition of Ten-Tec TV. Tonight on Ten-Tec TV, we are going to talk about CW operation and specifically how to zero beat a signal, a traditional method, how to zero beat one using the spot function on the Orion 2 and our other rigs, how offset and tracking side tone work, and the difference between LCW and UCW operation on one of our transceivers. Sometimes on other manufacturers' transceivers that's referred to as CW reverse, for example. Okay, you can see here I've got the Orion 2 in front of me. I'm going to pull this camera up just a little bit so I can see the screen a little bit better. The first thing I'm going to do is tune in a loud CW signal and show you what the traditional method of zero beating a CW signal would be. So, let's see if I can find one here. Go to this one. Okay. This signal that you hear here, tuning high, tuning low. To zero beat a CW signal, this is the old way we used to do it, would be you essentially have a little bit of an offset, and that's the tone that you hear. That's probably about 600 hertz or so for an audio frequency. You would tune down to where the signal disappeared. That's what we call zero beat. That was at the carrier. So listen to this. Okay, now it's disappeared. Now we would tune off of that. Until the CW signal was heard at approximately the frequency of offset from the carrier, and that would be the place that we would then transmit. You don't want to be, let me wind this filter out a little better example. You don't want to be up here, and you don't want to be down here either. You want to kind of be where CW sounds like a natural tone. Now, in the old days, we had to do this manually, essentially, to figure out where you should be. What we've always told people is, hey, if you can hear a CW signal, then you're probably approximately on the right frequency to start with. Now, what we've done with modern transceivers, essentially, is we put a spot function in so you can zero beat a given signal by matching the tone of the spot function, which is also the side tone, CW side tone, to the received signal. Now, you can hear the signal here. I'm going to press the spot button. I hear that tone. Oh, now you stop transmitting. I'll find another signal here in a second. That tone you hear is also the tone of the CW offset. I'm going to plug this key in here and transmit for a second. You can hear. Same tone. Okay, so, get this wire out of the way. Let's find another CW signal. One. Okay, so I'm going to push the spot button and match the two tones. Right there is zero beat. The tone of the received signal matched the tone of the spot button. Let's see if I can find another signal here we can use as well, now that he's turned it over to the other guy. There you go, right there. Couldn't be easier than that. Okay, so you're probably wondering now, what's an offset tracking side tone? You can hear as I'm tuning across this that is the offset I'm setting. There's 500 hertz, 600 hertz, 750 hertz. That tracking side tone is also the side tone value that you hear while you're transmitting, and also determines where you should be listening to CW. Now, there's a group of CW operators, particularly guys that are involved in DXing on the low bands, that feel that using a very low CW offset that you can copy weak signals in noise better than listening to a higher pitch like this. They usually will take the spot function and tune this down to maybe 400 hertz or so. So when you're listening to CW, with a low tone like that, you need to match it to that so you have the proper side tone when you're in offset when you're transmitting. Like I'll give you an example, you'll hear it now. You can hear how low that tone is. Now listen when I move it up. Okay, let's talk now for just a second about what the difference between LCW and UCW operation is. And essentially this relates to zero beat as well. LCW and UCW refer to which side of the carrier frequency you are listening to a CW signal on. On lower CW, you will be listening above zero beat, while UCW will be exactly the opposite. I'll give you an example of that. Let's see if we can find a signal to listen to here. Let's see. Move the cursor to right here. No, that's not CW. Okay, I'm going to tune toward the signal. As I tune low in frequency, you get down towards zero beat. And you hear the carrier, you hear the CW transmitted above the zero beat frequency. Now I'm going to switch over to upper CW. Now it's going to be exactly the opposite of that. So I'm going to find another CW signal here. Okay, now, zero beat is now above where you're hearing the signal. And as you tune down in frequency, you hear the signal. As you get above it, you're not going to hear it anymore. I got two guys on the same frequency right now. Okay, I hope this discussion has proven informative tonight. If you have any questions about this or any other questions about Ten-Tec amateur radio equipment or anything else we can help you with, please feel free to contact us at 800-833-7373 or via our website, www.tentec.com. Or you can send us an email at sales@tentec.com. If you want to address it to me personally, just put attention Scott W4PA on the line and I'll get it. 73 from all of us at Ten-Tec for another edition of Ten-Tec TV.